My name is Stefan Krenn and I'm going to introduce the concept of issue hiding attribute-based credentials. In an attribute-based credential system or ABC system, we have users that receive digital certificates or credentials from issuers. For instance, when the issuer is a university, such a credential might certify the name, the date of birth, the university, or the validity period, so the semester of the current credential. The user can now use this certificate in order to authenticate towards different service providers in a privacy-preserving fashion. For instance, when the user wants to buy a train ticket in order to receive a student discount, she might be requested to reveal the current semester of her student ID, but nothing else. So it's only important that she's really currently subscribed at the university. Similarly, when the user wants to authenticate towards an online service, she might be requested to reveal her birth date to prove that she is old enough to access the service. Now, ABC systems allow the user to selectively decide which attributes to disclose and which information to keep secret, and they ensure that different actions of the same user cannot be linked. However, attribute-based credentials typically disclose the public key of the issuer that certified the information to enable the relying party to check whether she is willing to accept information certified by this issuer or not. But unfortunately, this by itself can already be a privacy bottleneck. Just imagine a student from country A that visits country B and buys train tickets in country B. Now, the student only needs to prove that she is currently subscribed at some university, but there might not be too many students from country A traveling in country B, so by revealing the issuer's public key, the train provider can link different actions by the same user, because the train provider can re-identify the user simply based on the issuer of the certificate. This problem is addressed by issue hiding credential systems. In such a system, the train provider, in our example, would specify the set of all keys it is willing to accept. For instance, all public universities in a specific region or a country or Europe. And the user would receive from her mobile phone the notification that the company wants to access the current semester of her student ID, and that the train provider would be willing to accept exactly these universities, and this could now be a long list, for instance. If the user now agrees, her phone would compute a so-called presentation token that only reveals the semester, and it would prove that the credential was issued by one of the keys accepted by the train provider, but it would not reveal the precise university the user is studying at. So the anonymity set and the privacy guarantees of the user would strongly increase compared to traditional attribute-based credential systems. In our current solution, the computational complexity for the end user is independent of the number of keys accepted by the relying party, so there are no scalability or efficiency drawbacks to be expected. We are currently working on an implementation in order to receive first benchmarks for our scheme, so stay tuned for updates, and thanks for your attention.